Hello, Keith Rucker here at VintageMachinery.org. So this will be part 2 of making the back plate for my safe dial, what we've been working on here for a little while. And in my last video, if you remember, we kind of ran into a brick wall when I didn't really have the right tool to get in here and measure this or to deburr the back of this hole that I punched through here to get a good measurement. And I told you guys I was just going to stop where I was at. I was running out of time for that day anyway, and pick up a few new tools that I needed to get this done. So it's about a week later now, and I do have some new tools, and we're going to get in here and show you how we're going to do this. All right, so the challenge that we had was measuring the thickness of this piece in here, and several of you guys gave me all kinds of really good ideas on ways we could do this, and I was going to kind of discuss a few of those with you just because I want you to kind of see my thought process on this and why we decided to go the way we did. So actually, I think the first thing I'm going to do is talk about deburring the back of the hole here. And first off, let me show you what we got. So I purchased this little deburring tool made by Noga. You've probably seen some of these. I think Adam Booth has showed some in his videos, and Tom Lipton has showed some from sets that they've gotten. And I really like this tool, and it's one that I don't have. And basically what this allows you to do is come in here and kind of reach in here. I'm going to move my arm so you can see this, but reach in there and kind of work the back side of this hole. So if you got a blind hole you need to deburr, this is a great tool for doing that. I've already deburred it off camera, but you can kind of see how this kind of reaches into a hole to do that. So several of you guys commented about why not just reach in here with this boring bar. You got the back angle on here and deburr with the back of that. And normally I'd say, yeah, that'd be a great way of doing it. However, I've punched the hole in here so far with a drill bit. And some of you commented that it was drilling a little bit, or it drilled a little bit off center, and that was quite honestly because the grind on my drill bit wasn't the greatest in the world, but I drilled it undersized, so we're going to bore it out, and I haven't bored it yet. And the reason is because this boring bar that's in here is actually too big to go into the hole. It won't bore there. I'm going to have to change the boring bars, and I'm actually going to use this little small boring bar right here to reach in there and do that, because that's the only one I've got that's small enough to reach in there and do it. If you look on it, this angle it's got a little bit of relief to it, but it's really not something I can deburr with. So yeah, that would be great if my hole was a little bit bigger and I could actually use this boring bar to deburr, but I'm going to have to swap those out. So that wasn't going to work for me. So, you know, the other one was, why not just take it out, deburr it, put it back on the lathe. Well, I've got everything kind of lined up, and yeah, I guess I could do that, but that's really not the route I wanted to go. So anyway, we've got this Noga, and that is doing a very good job, and I've got the back of that deburred. So next thing was getting the depth, and some of you guys said, well, why not just slide a steel rule behind here to get a bottom in there, and then you could come in there with all kinds of tools and measure that. And again, that would be a good way of doing it, but before I had that hole deburred, I couldn't get this back there because it was, or I could get it back there, but I couldn't get it up flush to get a good level or a good bottom to measure off of. And even so, I'm not crazy about this approach, just because if there is any burr or whatever, and quite honestly, it's really difficult to hold this scale back here and get it up good and tight, and without having an extra hand to measure with, I really couldn't do that either. So yeah, it would probably work in a pinch, but instead what I have decided to do is to get a hub micrometer, which is actually made for doing exactly this kind of measurement. Now, if you've never seen a hub micrometer, you know, it's basically just like a regular micrometer, except instead of having that big long arc, it's made to go down inside of a hub or a bore to measure a thickness. Obviously, boring out a hub in a pulley or something would be a prime example. So I was able to find this one here. This is a Shear Tumica, I think. No, excuse me. This is a Moore and Wright hub micrometer, a 0 to 1 inch hub micrometer made in England. And I was able to get this and a couple other tools that I'll be showing you guys in my next odds and ends video to make this measurement with. But with this, you know, I can now come in here with that back deburred, get in there and get a very easily measure that. And actually when I measured this, I'm about just a little bit actually under the 250 thousandths I was shooting for, which is going to be fine. Again, this is just kind of for practice. And two, the places going in is actually, I think, really measured about 235 thousandths. I was going with 250 just to kind of give me some clearance. So I'm not too worried about that, but you can see how this hub micrometer reaches in here. And there's some other tools that could be used to do this. This is by no means the only way of doing it. I think another way that somebody suggested was to, again, put a scale or something behind it and come in here with a dial indicator, indicate off of this and indicate off the bottom, you get your measurement. And that would work too. But again, the hub micrometer here I think is going to give us probably the most accurate measurement that we can get, because it actually allows us to reach in there and get up off of the edge where any burrs may be and get a really good micrometer measurement. And this is a tool I didn't have. It's one I've been looking for. And hey guys, it gave me an excuse to get a new tool, so I took advantage of it. So the next step in doing this that I'm going to do is we need to go ahead and get the diameter, the outside diameter, or the inside diameter here inside of this, where the dial will just fit down inside of that. So this measures 3 inches across, and what I want to do is probably shoot for about 5 or 6 thousandths oversize. You know, we want to have just enough room in there that can freely turn without having any interference, but yet have it pretty close. You know, I don't want to press fit, I don't want it touching anywhere around, but I want it to be pretty tight in there without leaving a big gap. So we're going to use the same boring bar as a tool to kind of reach down in there. And I've already got a little mag mounted indicator set up on my carriage down here, so that when I come in I can see exactly where 0 is and go to that depth and know that I'm not going below that. I could, if I wanted to, set up this carriage stop that I built to actually give me a positive stop, but I think I'm just going to use the indicators because I can kind of see where I'm at. And anyway, either way would work. So let's get this thing fired up, and we'll go ahead and basically bore this diameter on the outside or inside there to match the safe dial. All right, we'll start by just getting this cleaned up in here. Just going to touch off and get a good straight bore all the way down. And then we'll get a measurement, starting measurement to start from. I got about 150 thousandths that I need to take out of there still. Alright, so we're about 100 thousandths shy of our target, so we'll take about 100 thousandths more and measure that. Probably not all in one pass. Let's shoot for doing that in 2 passes. So I'm going to take 2 for, we'll start with 60 thousandths on this first pass. That took a little more than 60. We need about 15 thousandths more. Or about 20 thousandths more. Alright, that was right what I dialed in. 10 thousandths, I need 10 thousandths more. That's right on the money, that's just what I wanted. All right, real quickly show you where we're at now. So you can see the dial fits right in there, just like I want. I'll also note, I don't know if you can see this or not, but when I bored this, I actually left a little bit of a ring right around this outside that's just a little bit higher than the back plate. And I did that just to give that outside ring something to write on. And this is kind of a sample piece that I got from the local safe company. It's messed up, but they kind of gave it to me as an example of what this will look like. And if you look, there's that same little ridge back in there. So basically the only part of the dial that is actually touching the back plate is just this little ring around the edge, which is going to be right on the money. So now my next step here is I want to come in here and take this thickness down so that this basically matches the thickness there, which should be about 200 thousandths. And I want to basically machine that off, and then we'll bore out the inside. I double checked my measurement here, and that's actually 100 thousandths, not 200 thousandths. I was going off of memory, which is why you should always check these things. And I've already faced the top of this, and I came in with my depth mic and just got right down on that lip that I machined. And I'm about 223 thousandths, 22 thousandths off the bottom there. So I got about 122 thousandths I need to knock off of this height there, and we'll just use the same boring bar tool that we've been using to do that with. I've got my indicator set up over here again like before, and I just want to kind of, after making that first pass, come in here, get a clean measurement. All right, I got about 70 thousandths still to cut. I'm gonna take another 50. It should be right there. And I need 22 thousandths now. Using the dial indicator right there. Should be flush. Let's take this out with a dial now, put the actual dial in. Looks like we got a little burr in there, but all right, that might be just a little bit high. But I think we're going to leave it like it is. That's a good fit. I've got my smaller diameter boring bar in here now, and we're going to come in here and punch this through and get that up to the right diameter, which should be 0.950. So 950 thousandths is what we're shooting at on that diameter. So let's bore it out. That's going a little bit faster than I want. Let me slow that feed down. I will mention that this bore is not super critical. The 950 thousandths is actually going to be a few thousandths over what I'm shooting for, so I'm not too worried about getting out my snap gauges or anything. I'm just going to use the calipers to measure this, and I'm about 910 right now, So we got about 40 more thousandths to go. And we'll dial in 20 more thousandths first here. Sneak up on it. All right, 20 more to go. Dial in another 20. That one was dead on. And since that's my final cut, I'm gonna back that out so I don't drag that back through. And that should be right on the money. And we'll get the calipers out just to verify. Right on 950. All right, again, time to do a little deburring. I'm gonna use this little Noga tool to come in here back behind this and just kind of give that a light deburring. That feels good. And we'll use a similar tool here. This one's not a Noga, but just give a light deburring on that. And probably also just going to do this real lightly. I felt a little burr on there. That feels good. All right, so that is pretty much just like we want. All that's left to do now is finish the outside of this. Now to do the outside diameter, what I'm going to do is I'm going to make a little fixture again that this will mount up on, and we'll turn that as the last step. Now some people asked me in my last comments why I didn't do this while it was on the stud on the back, and you know, I probably could have, that'd be fine, but the truth is I want to make sure everything is running real nice and true, and we're not getting any run out in this part. It's not going to be spinning. It probably wouldn't even be that noticeable if it was, but I just want it to be dead on, and I think the best way to do that is to actually turn this outside based on this inside bore, which will match this bore right here because they're both turning the same operation. And if I got that running perfectly true, then my outside should be running perfectly true with it as well. So we're going to take this out now and make a little fixture real quick to mount that on. So I've just got a piece of unknown material stock in here that we're going to make this little fixture out of. And we'll start by facing off the front and just cleaning up a good surface here. And my thought is of course when I make it, it's going to be running perfectly true in this chuck, but by turning this down just enough to clean it up, I'll zip this off, cut it off here, get this rough material off. And that way when I come back later to do this, I can put this in the 4-jaw chuck, indicate it in, get it running true, and be able to use this same fixture again later on. So let's go ahead and get it kind of cleaned up, and then we'll start making the fixture itself. So now what I want to do is I want to turn a step on here that this hole is going to basically just mount right up onto. So we want that to just be just a few thousandths under that diameter. And remember, this is a little less than 250 thousandths thick right here. I'm probably just going to do this 200 thousandths. It doesn't have to be flush with the top. In fact, I don't want it flush with the top. Just enough to kind of register it on there. So I've set my indicator up down here on the lathe again to kind of give me a stopping point, and we're just going to whittle this thing out. All right, let's check and see where we're at. I haven't faced the back of that flat yet, but all right, that's fitting up on there just right. And as you can see, it's just a little bit below the surface here, and that's fine. We're going to drill a hole in here, tap it, and we'll actually take a big washer and kind of just clamp this whole thing to this piece. But I want to get a good flat surface behind this, because that's really what's going to be registering against. I want to have good contact all the way around. So I'll probably do it off camera, but I'm just going to face the back of that out, and we'll get to drilling the hole. So now we're just going to tap this in. I'm just going to use a hand tap here, and as usual, I got my tap follower. Again, this is just a little spring-loaded center that goes in here to kind of keep everything lined up. And as I go in, we'll tighten that up, and we'll just spin this in by hand using again a hand tap. So we've got a nice shoulder here and a nice piece there to mount this on. This will come up, and that'll give me a lot of contact back here in the back, which is basically what's going to drive this, is this being sandwiched in here. So I've got a big washer that we'll put on here, then we'll put a smaller washer on here and kind of sandwich it all together. And that's tapped 1/2 inch 13, so we'll just run a 1/2 inch bolt down in there. Try to get that somewhat centered up. It really doesn't matter. That should hold it good. And that should allow us now to turn that outside flange. And again, it'll be turning on the center based on the center of the dial socket there, as well as on that inside bore. So this outside should be running perfectly and true with the inside. So we've got everything mounted up here. I have my compound set on 30 degrees, which is to match the same angle as on the front of the dial here. I just want that to kind of blend in and go down. And then on this outside, we're probably going to put a little decorative bead around the outside edge. But for right now, we want to go ahead and get this trued up and get that angle on there. So I've got a cutter set in here, and again, I've got my compound set on 30 degrees. So let's go ahead and machine that in there. All right, guys, slight change in plans. I realized when I started machining this wasn't blending in the way it should. I went back and grabbed the sample that I have and realized that that angle is not the same as the face of the dial, but instead it's at 45 degrees, which should allow me to get in here and clean this up a little bit better. So I've readjusted the compound on my lathe to 45 degrees, and we're going to go in here and put a little different angle in there and see if we can straighten that out. We're going to stop right here. All in all, actually, this looks like a pretty good casting as far as the part that's visible. There's one little tiny inclusion right there, but you know, I'm really not even worried about that. This is actually, I think, a usable piece. My original plan was I was going to put a little bead on this outside edge. As it turned out, I messed up a little bit. I turned this outside diameter a little bit too small for that. It needs to be probably about 100 thousandths bigger in diameter, and then I would have had enough material on that outside edge to go in and bead that over. So I'm going to recast these when I do my other ones, even though this is a usable part. And actually that profile does not look bad like it is, but I really like to look at that little decorative bead. So again, you know, this is a sample piece right now for me to practice on or what have you. So, you know, I'm happy with the results. So we'll go ahead and take this off, and I think to finish this video up, we'll take them both back home and kind of test fit them onto the safe and kind of see what they look like, so you can kind of get an idea of what this is looking like so far. So we'll cut for now and bring you back when we get back to the home shop. Back in the shop now, I've got the door of the safe here up on the bench, and we're going to do a quick test fit here. Just kind of see everything works, see everything looks, and see if we need to make any adjustments to our patterns or design as we move forward. So let me zoom you in here, and we'll kind of show you guys how this all goes together. So as you can see, we've got this little raised up stud here, and the back plate will fit down right over that, and this worked out just perfect. I'm pretty much flush with the back of this to the height there, and then again we got this little lip around the edge. It's just a little bit higher, so the only really bearing part of this is right around the edge, and all this in the middle is not really touching anything. Now in the final version, we will drill and countersink a couple of holes here that will have some screws that will go down and screw this in place so that it doesn't turn. It's going to stay stationary, and of course there'll be a line up here at the top that'll be that guide for lining your numbers up on the dial. And then of course we got the inside diameter there, and on the dial part itself, that fits down right inside of that hole and fits down right inside of the outer ring. And as you can see, everything works just like it should. And of course, you know, we got these inclusions. It really does not look good at all. You know, I just would not be happy with that in a final version. But anyway, we're going to recast all that and fix that. But all in all, I'm happy with this. I think, you know, the design's working. Everything's pretty much good on this. Again, the only slight change I would make would be on my back plate here. I need to make the diameter just a little bit bigger so that I can have room to put that little bead around the edge, just to kind of break this up. This does not look bad, and I think that would be fine like it is. But again, I really like that little bead around the edge, and put that one up here so you can kind of see it. It just kind of gives a little offset to that, makes it look a little bit better. So we're going to try to emulate that in the final version. But all in all, I'm real happy with it, and I think we're ready to move on in the safe restoration, or at least after we get this done. Of course, we'll have to go back and remake these, but we're all ready to move on with the rest of the safe restoration. I have about got all of my painting done here with just my base black, and we do need to come in here and do some basically pinstriping, I guess you'd call it. On the original, there was some gold stripes around this, and I'm going to go in, and I got some gold paint that I'll use for that. I did get some of this 3M tape, pinstriping tape they use in auto body repairs and stuff. This is supposed to leave a nice, real good straight line that we can put on there, and it's supposed to seal up to keep the paint from bleeding up underneath it. So hopefully this is going to work. I'll have to come in here and mask off. At least that's the way I'm going to do it. I'm going to mask off the areas and then go in here and basically paint the lines in here, and then pull the tape off to get some good straight lines. If I was good at pinstriping, which I am not, you know, you could do this by hand, and actually the original was probably just done by hand. But when it comes to painting, guys, that's not my specialty, and I'm not really capable of doing that. So we're gonna tape it off. But anyway, that's kind of wrapping up this video. I hope you enjoyed seeing this. And again, we're not quite through with this. We're gonna have to go back and do some more casting, as we've already said. But we'll get to it very soon. Thank you guys for watching. Thank you again to all my many subscribers, and please leave me some comments. We'll talk to you later.